Assalamu alaikum. Hello everyone. My name is Abdullah Al-Khaldi. My ID is 2023068850. Today I present my individual engineering project for energy, environment and sustainability. My research title is Decentralized Residential Solar PV Integration, aligning Bahrain Vision 2030 with SDG 7 and SDG 13. Dr. Rakesh Babu. This project examines transition urban housing from fossil fuel dependence to self-sustaining micro generation. So let's begin. For the research context and SDG aligning for the Kingdom of Bahrain, almost initially on domestic natural gas for electricity, over 95% for gas-fired combined cycle balance gas. So that will be my research analysis. Decentralized residential solar PV as long-term solution to these challenges. Gas field degrade and solar comparing centralized compared to circle gas with decentralized rooftop PV gas plan, and also provide reusable supply but require conditioned fuel and emit greenhouse gases. Rooftop solar need no fuel in operation. Production zero operational gas house ambitions, and liver aids in Bahrain strong solar annual horizontal aeration around 2100 kilowatt hours per meter square. Solar required higher up front capital but has minimum operating cost over 25-year life. So that managed with EWA record export excess daytime generation is export to the grid. The smart meter credit the customer lowering bill while supplying a clean energy to neighborhoods. So now for practical and calculation. To provide this concept mathematically performed an energy audit for family villa in Bahrain. I calculate the potential solar yield using the standard, and after calculation we get area of 32 meters square, and also for efficiency will be solar panel of 19% and local panel solar a residence of 2100 kilowatt hours per meter square per year. Finally, BR, which is performance ratio of 75% according for wiring and inverter losses. By running those numbers, we find that a residential solar system can generate 9,576 kilowatt hour of the clean energy per year. That is about 798 kilowatt hour per month. This is the successfully offsets 23.5% of villa total baseline utility demand. This graph compares seasonal household composition, which is blue, with a projected PV output for the orange. Household load peaks in summer due to air conditioning. PV output also peak on summer below than 1000 kilowatt hour, meaning PV helps shape peak cooling demand on the national grid. Now we're talking about social and ethical dimension. This key social and ethical issues and capital cost barrier can exclude lower income families and slipped incentive deter landlords from the investing in the rentals. Despite this standard of 6 kilowatt residential system avoid roughly 4.9 metric ton per year and conserves gas for high value industrial use. Actually, I have apartment in Bahrain, so I have also neighbors. I held actually a seminar with families, my neighbors available in Bahrain. So I discussed with them and explaining EWA net metering claims, impact and bill optimization per post quizzes showed understanding of utilities credit improved from 1% to all 5. I obtained a sign constant and preservant per university ethics. So now Bahrain Vision 2023 DG 7 and SDG 13 will explain more about this session. In conclusion, the centralized residential PV is technically feasible and support Bahrain Vision 2023 and national target for renewable. This project strengthened my practical audience skills and showed how household measures can contribute to national sustainability goals. Thank you for your time.